Oh, you guys like how much shit he's going to pack in this one day? More. Stay with me now. This is kind of neat. I'm going to explain to you why the standard deviation formula for a sample is a little bit different. So minorly different. But the concept is kind of like you got to follow along. Okay. There's currently an average age in here, right? All right. If I took a row at random, do you think their average age would be the same or different from the average age of everybody? Most likely their average age is going to be, any sample I take, it should be close to the average, but is it going to equal the average? I'm going to put money on it not equaling the average. I'm sorry. You guys semi with me a little bit. If I take a sample, if I pick a good sample, the average should be close. But invariably, if I take a row that just happens to have more young people in it, right? Some youngins. You guys with me? Then their average age is going to be a little smaller than the average of everybody. Are you guys with me? Okay, that only makes sense. So if I calculate these guys' standard deviation, their standard deviation, will these guys be closer to their own age or to the average of everybody else's age? Closer to these average age or everybody's average age? These guys are going to be closer to... So let's say the average age of everybody is 26. And let's say the average age of these guys is 22. Each of them, would you guess that they would be closer to 22 or 26? They would be closer to 22, right? So if I calculate the spread of these guys' data, it's going to be smaller than it's supposed to be, because they are all going to be inherently closer to their own average than they would have been for the average of everybody. Does that make like the tiniest bit of sense? And you're like, I'm just waiting for you to show me the formula. All right, I already did. It's the only thing. I'm trying to explain why the bottom becomes n minus 1. So if their spread is smaller than it should be because they are closer to their own average, how can I make that bigger? By dividing by less. So instead of dividing by n, we divide by n minus 1, which is nifty. And there's a huge, I'm not sure how much I want to get into more of the why. That's enough right there to understand why I'm dividing by something else than n. It's an adjustment because it's just a sample. So if I have a population, I'm going to divide by n. If I have a sample, I'm going to divide by n minus 1 in the formula. And you guys see that on the paper? And of course, also, instead of using sigma, we're using our letter S. So mu population mean, X bar sample mean, sigma population standard deviation, S sample standard deviation. Use Greek letters for population and then R letters for little samples. So see, I'm divided by n minus 1 instead. That is an adjustment because it's just a poor little sample. Okay, do it. Clear as mud, Jeff. All right, shit.